pleasant day to all of you. I am again Engr Fresado, a fourth year computer engineering from the University of Pulangi, belonging to section 4B, and I am here to explain the laboratory activity output that I have made for laboratory activity 9, which is all about digital convolution. So in this activity, the objective is to perform convolution using manual and built-in Python function. And to verify the convolution results, so convolution is an formula to find the output signal by multiplying the values of the input in the input signal and then adding it. So I will explain the code. So for the code, we first declare the packages that we need, so numpy and not.lib. Next is to define the example signals. So this was put in an array, as you can see, and to also put the indices. So we have also an array with the range of x and h, and then we perform convolution using the convol function, and then we put the convol function in the n underscore y variable. Next, we define the manual convolution function, where we define the length of the convol function as the length of the input added by the length of the impulse minus 1. And next, we perform a for loop where we multiply each value with the value of the impulse signal, and then we add, and then we put the result of the process in the y manual variable. Next is we compare the two results. So if it's match, we have a true, and if it's not, we have a false. So it means that it is not equal. Next is to plot this. We use a 12 by 6 figure, and we use the subplot function. So we put first the input signal, then the impulse response, and we then put the convol output in the third subplot. So that is all, as you can see here in the results. And in the terminal, it will check. So we have the built-in manual. It is match, yes. So you can see here, this is the input signal, this is the impulse response, and this is the built-in. So for the guide questions, we have here, so what is the length of the convolution output? So we have m plus n minus 1. So it has also here if the result using the manual ended with if they are identical. Yes. So what happened if each of n is replaced by a delta function? So it does nothing to the input, since the delta n is a unit impulse signal where the amplitude is equal to 1 when f is 0. So it does nothing, since you know the amplitude is 1 when f is 0, and when we convolve, it does nothing to the input. Nothing is shifted to the right. So give our real world example where convolution is applied. So blurring in many image editing apps where we put up blur to a photo and when then we apply convolution